Okay, good afternoon, everyone. Okay, we're gonna today keep working with how to prove equality between sets. So let us remember, in general, if you have two sets, A and B, A is equal to B means that A is a subset of B and B is a subset of A. So to show equality, we have to show that every element in A is an element of B, and every element in B is an element of A as well. Okay, so as in opening, before we go back to the properties I started last time, as in opening, I want you to prove the simple fact. So suppose A is a subset of a universal set U, and I wanted to prove the very intuitive fact. If I take A union the complement, what should I get? Quickly. It's in my set A. If I take it union the complement, what should I get? Quickly, I want answers.
Did you get the universal set?
We get the universal set. Okay, so if this is A, that's my universe. A union A complement is the universal set U. Okay, now we want to prove it. Okay, intuitively it makes lots of sense, but we're gonna prove it. So this is inequality. So I need to prove two facts. So I need to prove that this is a subset of U. Then I need to prove that U is a subset of A union A complement. All right? Okay. And let us start with the first one. How do we prove inclusion? We take an element in here and we show it is in here. Is this obvious? Is A union A complement necessarily in U? So let X be an element in A union A complement, and I have to tell you that my X is in U. Okay. All right. What does mean A union A complement? Means X is in A or in A complement. Okay. But so we have the two cases. Suppose X is in A, because I have an or, so my X is either here or here. So case one, if X is in A, then X is in U. Why? Come on, guys, answer so we can do a lot of problems. Why, if it's in A, it necessarily has to be in U?
Because U is A union A complement. So if it's...
No, we have to prove that. We have to prove that.
Oh, okay.
Because U is what?
Well, A is a subset of U, I guess.
Right.
So
that's right.
If,
yeah, because A is a subset of U. U is my universe. So X is in U because A is a subset of U. U is the universe. That's everything is in it. Now, if X is in a complement, suppose X is in a complement, also X is in U. Simply because what's the A complement? A complement is everything in U which is not in A. But as I always said, they have to be somewhere. So there are something in U. Because also a complement is in U. So that's why I told you this part is easy. So regardless what X is, whether it lands in A or in the complement, A is in U, it means X has to be in. Okay, that's the first part. So it's a simple part, but just the idea is how to really handle those equalities. Part two, I want to show you that if X is in the universe, then it is in here. So I start with an element in the universe, and you have to tell me that it has to be in A union A complement. All right? How shall I go from here to here logically? Go ahead. What do you think I'm going to go? I need to go from here to here. Okay, how shall I do that? Anybody wants to pitch in? So I'm taking any element in U, in the universe, and I'm going to tell you that this element is in A union A complement. So how can I kind of connect? Actually, I need only almost one line to connect.
If X is in U, then X, sorry.
Mhm.
No, that's sorry.
No problem. Any ideas are welcome. So let X be in U. Then either X is in A or X is not in A. Does this logically make sense? Does this make sense? If X is in U, it's either in A or not in A. There is no other, nothing else can happen. It isn't in A or not in A. So if X is in A, so I kind of imposed this union by taking those cases because that's everything. Now, if X is in A, then X is definitely in A, as we mentioned last time. It's in A, so it has to be in A union anything. Whatever this anything is, I don't really care. I'm putting a union. And if X is not in A, means X is in A complement. That's the definition of not in A. It's in U, not in A. Hence, X is again in A complement union A. It's an A complement, so it's an A complement union anything we add to it. So regardless, so in both cases, so I pick an arbitrarily element in U, and we show that this element is, regardless where it is, it's always end up in A union A complement. So in both cases, the cases I'm talking about are those two. X is in A union A complement. So I start with any element in U, and basically I told you, if you have an element in U, that's really the picture. It's either here or here. If it is here, it's in A union A complement. If it's here, it's also in A union A complement. So in both cases, X, so U is a subset of A union A complement. Okay. And since we proved both inclusion, it means the universe is equal to A union A complement. It made sense logically, but now we're proving. So the idea is how to prove that those equality hold. Okay. Yeah. So we're going to practice those today. We're going to practice those ideas today, how to prove things. So that was an opening. The last thing I did last time was to prove the following property that we call the distributive property, one of the distributive property of set. Distributive property. And we proved the following last time. If you take a set A, intersect B union C, okay? It's equal to, that's what we did last time. And why it's called distributivity? Because it should remind you the distributivity of numbers. So if you have A times B plus C is AB plus AC. That's what distributivity of number is. For sets, we have something similar. So here we're changing, that's intersection and that's union. That's very important. So it's equal to A intersect B union A intersect C. Parentheses are absolutely crucial. Okay, so that's what we call distributive property. So the distributivity of intersection with respect to the union. That's what we really proved last time. And usually how we can somehow read this. We can read it like this. This equality tells me that X is in A and in, sorry, X is in A and X in B or in C. X is in A or and in B or C is equivalent to say X is in A and B or X is in A and C. Okay, so let us read it one more time. What does distributive property tells me? If X is in A, so it's already in A, I know where it is, and it's either in B or in C, make a lot of sense. It means my X is, of course, it's in A, so it's either in A and B or in A and C. That's what the distributive property is actually telling us. Okay. Today we're gonna now do the other distributive property, the union with respect to the intersection. Okay, so we're gonna prove the following. Proof. And this time you guys have to try harder. We have to prove that A, union, B, intersect C. So I'm distributing the union with respect to the intersection is A, union B, intersect A, union C. Okay, so we're gonna prove the following. Since it's inequality, I have to prove two inclusion. I will start, I'm gonna ask you to prove the first one. I think this is hard, this is easier. The other one is not harder, but so first we're gonna prove this inclusion. Okay, so I'm gonna prove that if an element is in here, it has also to be in here. Right. What should be the first sentence I write? Now back to you. What should be the first sentence I write? Timothy, Tim, what should I start with?
Let X be an element of A union B intersects C.
Yeah, parenthesis. I start with you. And what's my goal at the end?
We're trying to prove that X is an element of parentheses A union B and parentheses intersect beginning parentheses A union C and parentheses.
Very good. That's what we have to prove. So we have to always to I where we're heading. Very good. All right. Tim, do you feel comfortable? Keep going. What does it mean X in A union B intersects C? It means where is my X? I want to head here logically. But if X in A union B intersects C, it means where is X?
It means that X is in A or in B intersects C.
Absolutely. And this is by definition of what?
By definition of union.
Very good. Okay, so we're gonna do it together. Now, what shall I do? So what is my X now? Do I know exactly where my X is? Do I know exactly where my X is? Yes or no? All of you. Do I know exactly where it is? Or?
I would say yes.
Okay, where is it?
Wouldn't it be in A?
No.
Yeah. No.
Why? Not necessarily. Not necessarily. Why?
Or statement.
Because we have in or. Okay, so where is my X for sure? I don't know exactly what it is. It's either in A or in B intersects C. And the idea is that we have to prove that regardless where it lands, whether here or here, this particular X I pick, regardless where it lands, it will end up here. That's really what I want. So what should I do at this stage? What shall I do?
You make two cases,
We
one
have
case.
another one. Exactly. We have to make two cases because I don't know exactly where my x is. I have to make two cases. Very good. The first case is, let us say my x lands in A. And I have to convince you, if x is in A, then x have to be in here. And then I take the second case where x is in B intersects C. So now who would like to lead me from here to here? If x is in A, why it is in here? Why it has to be in here? Watch carefully where we're heading. I want to show you, I want you to convince me that it's an A union B intersect A union C. You have to convince me it's in here and in here because there's an intersection. Okay, who would like to lead?
Since the x is in A, so x is in A union B and A is in union C.
So X is in A union B and X in A union C.
Yeah.
Is he correct? Is he correct? Within A is in A union B because A is a subset of A union B. So if something in here, it has to be in here. And it's in A union C because A is also a subset of A union C. So now I have X in A union B and in A union C. So X is in the intersection. So the first case is done. Okay. So if it lands in A, it has to land in here. Now case 2. So that's case 1. Now case 2. So case 2 is, let us say X. So I have two cases. The second case is X lands in B intersects C. And you have to convince me why, if it's in B intersects C, it has to be in here. So to connect dots, really, really connect dots. Okay, get going. Who would like to take over? So if it's in B intersects C, you have to convince me logically that it has to be in here.
Okay, so because the x is in B inter C, so x will be in B and x will be in C.
Very good. Proceed.
That's why A will be A union B and X will be in A union C.
Yeah. No.
And
Yeah. Now you're right, but let me write it correctly so you know how. Now, since B is a subset of A union B, since X is in B and B is a subset of A union B, so X is in A union B. We got the first piece. Okay? And the and is crucial. Since X is in C, and C is a subset of A union B, so X has to be, my apology, in A union C. So now I have X in A union B. So they are not really hard. It's just that you have to follow your nose and know where you're heading and connect that. And X is in A union C. So X is in A union B and X is in A union C. Sorry. So X is in A union B intersect A union C. So now we took two cases. In the first case, I convince you that X is in here. In the second case, I convince you that X is in here. So no matter where the X lands, whether in A or in B intersects C, it's gonna be in this set. So I have my first inclusion. So in both cases, okay, so in both cases, X is in A union B, intersect A union C. So I have my first inclusion. So A union B intersect C is a subset of A union B intersect A union C, and of the first inclusion. Okay. Now the second one. Now we want to prove the following, that A union B, this is slightly harder, intersect A union C is a subset of A union B intersect C. So let's see how we are going to do this. So we're going to, as usual, we take an X and we say, let X be in here. And I need to convince you that if it's in here, then somehow it has to land in here as well. All right, but to interact with it a little bit, because there is an intersection, it's a little bit harder because we don't have clear cases because of the intersection. So what do you think I should do? So if X is in here, it means X is in A or B, and it's in A or C. Anybody wants to pitch in?
So in the case where X is only in A, we can just say that X is in A, so X is in A, and that works on its own. And then in the case where X is in B and C, we see that it's also in B and C, and that's.
But why are those all the possible cases? That's what you have to justify.
Can we say like X is in A or and X is not in A?
Very good. I would prefer that, because by doing this, he's taking every possible scenario of X. So you cannot just say, okay, X is in A or X in B intersect C. I can tell you why there are other values of X. So when you split in cases, your cases should cover all the ground. Otherwise, you will be missing situation. Otherwise, you're telling me, okay, it's here, but I cannot accept that. You have to do it logically. Now, what Kai said is the following. He told me let X be in A. So X is in either A or B, and it's either in A or C. So he told me take the following case. Let X be in this. Then X is either in A or not in A. This makes sense because he's covering every possible cases for X. Even though it doesn't seem to follow very easily, but that's a very smart approach to do it. Now, X can be either here or here. Now I'm going to take my two cases. So case one, if X is in A, if my X is in A, then automatically it's going to be in A union anything. So in the first case, I landed in here. Now it's my second case. And that's where, suppose case two. Suppose X is not in A. It's not in A. Why? So it's not in A. Why we have to land in B intersect C? So go back to here. That's where your X is. If it's not in A, logically convince me it has to be in B intersect C. I still give you a minute to interact with it. Remember what your X is. That's what your X is.
If X is not in A, then X is in B intersect C, right?
Because.
Like,
You're right.
because
Without because, I won't accept it.
because if X is not in A, but X is in A union B, then X is in B.
Now
And if X is not in A, then
very good. Now you're making perfect sense. Okay, suppose X is not in A, but X is in A union B, and X is in A union C. That's where we know where my X is, because that's really where my original X is. Now, if X is in A union B, and X is not in A, in A union B, but it's not in A, then it has to be in B. It has no other way out. So if it misses A, it has to be in B. And now also, if, sorry. So, and also, X is in A union C, and X is not in A, then X has to be in C. So I have X in B and X in C. So X is in the intersection of B and C. Since it's intersection, it means X is in A union B intersect C. So in both cases, it means whether X is in A or not in A, my X lands in here. So I have my second property. So A union B intersect A union C is a subset of A union B intersect C. And that shows the second distributive property of the set. So that's, now we talked about distributivity of the union with respect to the intersection. So let me a little bit kind of go over the idea of the proof that we wrote. We said that X be in A union B and A union C. So we took two cases. If it's in A, I'm done. It has to be, sorry. If it's in A, it's in A union. If my X is not in A, my X is in A union B. So if it's not in A, it has to be in B, because it is in A union B intersect. If it's not in A, it has to be in C. So it has to be in B intersect C, hence it's in there. So that's really the logic of the proof. Okay. So these are another property we proved for set, but it's distributivity. And then I will summarize all the property we're trying to prove. So I'm using the property of set to learn how really we work with showing equalities between sets. Now,
See the conclusion.
that's what you want me to give?
Yes.
Very good. All right. Now we're going to talk about De Morgan's law for set. We've talked about De Morgan's law in logic, and now there is a De Morgan's law for set. And before I state De Morgan's law for set, let me ask you a very simple question. Now, I don't know which courses you guys are taking. I know you're taking my class. Okay, you're done. Suppose I give you A to be the following set. Okay, you don't have to write this. I'm just, suppose I take X to be A to be the set of all students at, let us say, PNW, such that the student is taking, let's see, which class I want. The geometry class. Is it 330? Is the geometry class 330, guys? You know?
Yes.
Yes. And B, all the students at PNW such that the student is taking, let us say, CS206. Okay, those A and B. Now, I don't know which classes you guys are taking. I know you're taking mine, so I avoided mine. And I want to ask you the following question. Is any of you in A union B? Is any of you in A union B? It means is any of you, one of you, is in A union B.
Yeah, I'm taking 330.
330, okay, so Rachel belong to A union B. Why she's in A union B? Because she's taking 330, so she is in A. Now, is any of you not in A union B?
Yeah, I'm not in it.
Kai, you're not?
Nope,
Because
because I'm not in what?
Not taking both of class.
right, because Kya is not taking A. What do you want me to write here? Because he's not taking 330.
I'm not taking either, so I'm not taking A or B. But
No,
And
no, you're not taking A
and
and you're not in A because you're not taking A and you're not taking B. Okay, the reason you're not in A union B because you're not in A and you're not in B. You're not taking 330 and you're not taking the other one. Not or, it's and because you're not taking both of them. So why am I bringing this to the picture? I'm bringing it for the following reason. So De Morgan's law for set. De Morgan's law for set. For set. Tells me the following. So if you have two sets A and B and the A, B subset of a universal set U, the universal set U. Okay, so I have a universe, but I'm going to talk about complement, so I need a universe immediately. And this is my A and this is my B. De Morgan's law tells me the following, that if I take the complement of A union B, means everything that's not A union B, what do I get? If an element is not in A union B, this element, so Chi was not in 330 union CS206 because he was not in 330 and he was not in CS206. So the complement of the union is going to be the complement of A intersect the complement of B. So the complement of the union turns the union immediately into the intersection. And the same thing for the complement of the intersection is the complement of A union the complement of B. Okay, we're going to prove one of them, not both. Probably you can prove the other one in your homework. So basically here, this is A and B. So what I'm saying is that if an element is not in the union, my elements are here. That's what it means, not in the union. So that's A union B complement. So if it's not in A union B, it means it's in this red. It means it's avoiding A and avoiding B. It's not in A and it's not in B. That's the picture. Now let us prove that. And I prove, and this is one of the proof where I have to use logic. I mean, that's the only proof where I have to use the rules of logic quickly. Let's prove this. Okay. Right. Again, I will prove one of them. Sorry, both inclusion, and the other will be the same. So we'll do exactly what we start. We start with an element in here. Okay, and I have to show you it is in here. All right, so let X be in A union the complement of A union B. It means that X is not in A union B. Definition of complement. Okay, and now I have to use logic in the following sense. It means that the statement X belong to A union B, this mathematical statement, that's the only place where logic has to be brought into the picture, is false. Is this correct? Am I making sense?
Yes.
Very good. What does it mean it's false? It's false. It means its negation is true. Okay, but what's the negation? That is the negation of, what does it mean X in A union B? The negation of X in A or X in B is true. So logic has to be brought into the picture. What does it mean? What's the negation? So that's my P or Q. So this is true. It means the negation of the or, it means this equivalent to say and is true. So basically, I'm telling you the negation of X in A or in B is actually the negation of X and the negation of B. So now we have the following. It means X not in A and X not in B is a true statement. So X is in A complement and X in B complement is true. Hence, X is in A complement, intersect B complement. Okay, so it's a little bit different than everything else, but that's the only proof where I have to go this way because we need the rules of logic that negate the or into the end, negate the or into the end. Now, the other approach is verbatim the same, but you go backward. So it's exactly as before, but moving backward. So I will not repeat it exactly as before, but moving backward. And let's see what I mean by that. So we do it exactly, but we move backward. It means we start with X is in here. It means X in A bar and in B bar. It means X not in A and X not in B. It means the negation of X in A and the negation of X in B is true. And then I use, so from here to here, that's what I'm using De Morgan's law of logic. Okay. It means this is true. Okay, the negation of that is true. It means the negation of X A union B is true. X is in A union B is false. X is not in A union B. X in A union B complement. So you go backward step by step, and then you get exactly the same proof. Okay. All right. So De Morgan's law for logic is that the complement of the union is the intersection of the complement. And the same thing, this is, we'll probably assign it to you as a homework, so we don't have necessarily to do it here. And the complement of the intersection is the union of the complement. Crucial to know that we are changing operation. Now, I'm gonna read it one more time. I'm gonna read De Morgan's law, so it will basically kind of totally stick to our mind. So let me read it. What do I mean by I wanna read it for you? So let us read this. This reads the following. X is not in A union B means X is not in A and X is not in B. So that's how we can avoid the union. The other one would read for us the following. X is the complement of the intersection is the union of the complement. It means X is not in the intersection if and only if X is not in A or X is not in B. Okay? Very crucial to work with those. All right. Now, this type of proof we're using, I mean, later on I will summarize as I promised. Today, right now, I just want to practice those ideas. This type of proof we're using where we take an element in here and we show it's here. Yes. Question. So the type of proof we're using, it has a name we're using. It's called element-wise proof. It means we're doing it element by element. We take an element in the first set and we show that it is in the other one. And we take an element here and we show that it is in here. Now let us do some more practice problems. I will set up the problem and I will give you a few minutes to interact with it and then we take it from there. So practice problems, the same ideas, nothing really new, the same thing, but just more problems. So practice problem.
Professor,
I'm listening.
what was the type of proof? It was
Element-wise proof.
Okay.
Element-wise. Why it's element? Because we take an element in one set, we show it's in the other set. That's why it's called element-wise proof. So I want you to do the following for practice together. Let A, B, C be subset of a universe. I want you to prove the following using the ideas we're doing. A minus B intersect C equal to A minus B union A minus C. And you want to do that element-wise. It means I want to take an element here, show it's here. I want to take an element in here and show it is here. Okay, so we're going to start with the first one. Okay. So we're going to start. I'll pick one of you to start with me and then we will do it together. Okay. Rachel, do you want to start? Rachel?
I'm here.
Okay.
I do better listening this time. I'm trying to keep...
That's fine. And who would like to? Emily? Emily, would you like to start?
Are we should we like start it like the way we did before where we had X as an element?
Exactly. Everything. Verbatim.
Okay.
Those are practice. Those are practice. So you guys get a feel for it. So what should be my first sentence?
Let X be an element of A. Would it be A minus B union C? Oh, so we use the whole first part. Hold on. Let me go back to my notes.
That's why I have to put you on the spot to keep you
It's
focused.
okay. I'm kind of with Rachel on this one, but I think it's just a lot kind of going on. But
That's all right. That's okay. I know it's hard at the beginning, but you'll get hang of it.
yeah. So it is minus B or C,
No,
not B union.
no.
B intersect.
We have to start here.
Okay.
period.
Yeah.
Where we have to head? Where should we go? You have to convince me, or all of us, we have to be convinced that if it's in here, now I can draw the Venn diagram. It's not hard. If it's in here, it has to be here. I have to do that logically.
Right.
Okay, very good. So I keep my eye here and I keep my eye here. I mean, I don't really lose track. Otherwise, I don't know what I'm doing. All right, now, what does it mean to be in A minus B intersect C? What does it mean, minus? Who would like to pick up? Michael, would you like to pick up? Means where is my
I got
X?
it. Here. It means that you're in A, but you're specifically not in the parts of A that overlap with B intersects C.
So I want one sentence. What does it mean to be in A minus C? Anybody else?
X in the A
X is in A.
Yeah.
and X is not in B inter C.
Exactly. Definition of difference. Okay, we follow our nose sometimes, I say. What does this mean? It is in A and not in B intersects. I want to head this way. Keep that in mind. Very good. Now, what does this mean? It's not in B intersects C. What does this mean to us?
X is not in B and not in C.
No.
No.
Why did I scream?
It's or.
Or. That's the heart of De Morgan's law. That's the heart of De Morgan's law. It's not in the intersection if it's not in A, or it's not in B. That's how I can avoid being in the intersection. Okay, I'm not in the intersection. It's either I am not in A or I am not in B. I'm not in both of them. So I'm not in here, not to be intersection. I could be still in B. If I'm not intersection, it means either I am not in A or I am not in B. I can still be in B, but not be in the intersection by avoiding A. And I can still be in A, but not being in the intersection by avoiding B. So not being here means either I am not in A or I am not in B. That's really what it means. Because that's how can I avoid the intersection. Either not here or not here. I don't have to be not in both. I don't have to be outside. I can be either not here or not here. That's how I can avoid the intersection. Okay. And if you're struggling with this, which is a lot of students usually struggle with that, I'm aware of it. So you can remind yourself. So it means that X is in A. So if you cannot really remember that, you should be remembering that. Not in B intersect C, it means it's in B intersect C complement. Does this make sense? But what does this mean? But De Morgan's law, it means it's in B union C complement. That's what De Morgan's law tells me. So what is my X is? So what is my X? So my X is in A and X in B complement union C complement. And X is in B complement or X is in C complement. So in case you really forget, not in B intersect C means not in B and not in C. Sorry, not in B or not in C. Okay, say, okay, if it's not in B intersect C, it means in the complement. But De Morgan's law tells me the intersection goes to the union. It means X is in B complement or in C complement. So what is my X is? So my X is in A, and my X is either not in B or not in C. And I keep my, I'm really never losing track. I know really where I am heading. So now X is in A and X not in B or not in C. So now we have, if you want, you can split two cases. So either X is in A and X not in B, or X is in A and X not in C. So that's really where my X is. So it's either in A and not in B, or in A. It is in A, I know that, but it's not in C. In the first case, in A, not in B, it's in A minus B. And now I'm starting. So it's in A minus B union A minus C. Now, if it's in A and not in C, it means it's in A minus C. It means it's in A minus C union A minus B. Okay, so let us a little bit see what we did. We started with an element here. I want to show you that it's landing here. I say, okay, what does it mean to be in A minus B intersects C? It means it is in A, but it's not in the intersection of B and C. So now I start to make sense. What does it mean not to be in the intersection? Not to be in the intersection, it means it's not in B or not in C. That's really what De Morgan's law tells me. And now when I hit this, I said, okay, X is in A, I know that. And where else? It's either not in B or not in C. So now I split it, means I know it's in A. It could be in A and not in B, or in A and not in C. So if it's in A and not in B, it means it's in A minus B. If it's in A and not in C, it is in A minus C. So that's really the logic we're using. So hence, in either case, we ended up in A minus C union A minus B. So we have the first inclusion. B is a subset of A minus B union A minus C. And I have the first inclusion. Okay. Now we're going to move to the other one. Okay. Can I turn the page? So let's choose the other one. Now I want you to show the following to me. A minus B union A minus C is a subset of A minus parentheses B intersect C. Parentheses are absolutely necessary in here. So that's the part I need to show. So this is my first set. I want to start with. I want to show that it's a subset of that. Means I want to show that every element in here has to be in here. So I start with an arbitrary element, and I try to show that I'm going to land in here. So let's do that. Okay, now what's the first sentence? Patrick, what shall I write?
Let X be an element of A minus B union A minus C.
Yeah. And where I should land? I should convince you that where is my X?
It's an element of A minus B intersect C.
Okay, so let's start. What does it mean to be? Patrick, if you want to continue, continue.
Okay. So let's see. I guess you probably want me to use De Morgan's law to convert the differences into complements, right?
It's not a question what I want you to do. The question of what do you think we should do?
I mean, I should probably do what you want me to do.
No, never.
Let's see. So we can rewrite A minus B as X is in A and not in B,
Mm-hmm.
right?
Yeah.
And we can rewrite A minus C as X is in A and not in C. So
How are you going to connect them?
yeah, and then you can say either X is in A and not in B, or X is in A and not in C.
So let's split them in two cases, since you have an or. Okay.
Okay, so case one, X is in A
Yeah.
and not in B.
So since we have an or, X is in A minus B, or X in A minus C. Right?
Yeah.
Why did I split them? Because it's a union. So that's the definition of the union. So those problems could be done in several ways. That's why I don't like to tell me the way you want me to do. Okay, but I'm trying to emphasize the idea of a union. Now I'm going to take the first case. Suppose X in A minus B. Okay?
Yeah.
Why it is in A minus parenthesis B intersects C. Analyze the statement. What does it mean to be in A minus B?
To be in A minus B, X is in A and X is not in B.
Right, and X is not in B. You always keep your eye, as you say, eye on the price. That's where I'm heading. That's definition of difference. Okay.
And because X is in A and X is not in B, X cannot be in B intersects C.
Correct,
And, because in order to be in B intersects C, you need to be in both B and C.
And it's not in B.
Yeah.
Right now here we're trying to connect. It is in A, but I know it's not in B. So what Patrick is telling me, if it's not in B, there is no way it can be in B intersect C. Because to be in B intersect C, it has to be in both. If it's not in B, it's definitely not in B intersect C. So that's what we're going to analyze now. Not since X is not in B, then X is definitely not in the smaller set. Not the smallest, not in B intersect C, because B intersect C is a subset of B. So if it's not in the larger set, it cannot be in the subset of it. Okay, so now what is my X now?
It's in A, but not in B minus C.
And not in B intersect C.
Yeah.
So by definition of difference, it is in A minus parenthesis B intersect C. I have my first case. Does that make sense?
And then the other part is the same process.
Exactly. Case 2 is verbatim. Case 2 is verbatim. Okay, so X in is verbatim. Instead of C, I'm gonna B. It means X is in A and not in C. Definition of difference. That's why knowing the definition of every operation is crucial to be able to work with it. So since X not in C, then X cannot be in B intersect C, because B intersect C is inside C. If it's not in the bigger set, it cannot be into a subset of it. So now X is in A and my X is not in B intersect C. So my X is in A minus B intersect C. Okay. So I approach the problem this way because basically trying to how we can basically follow our nose in a way by going through the definition and keeping an eye on the price. We go through definition and keep an eye where we're heading so we can connect that. So in both cases, we have X is in here. Hence, we have the inclusion. So A minus B union A minus C is a subset of A minus B intersect C. And now we have the equality that A minus, and actually if you analyze it a little bit, it actually makes sense. A minus B, this intersection turned into the union of A minus C. And that's the element-wise proof. It means term by term, element by element, we try to show that. Okay. All right, let's do some more practice problem. Which one I want? I would like to do 2 more. Let's see how much I can go. Okay. Prove the following, which makes sense also. That's not very hard. Okay, prove that. If I take A union B minus A, what do you think I should get? Draw a picture. So take A, what?
A intersect B.
No, this is A union B minus A. What should I get? Quickly, guys.
A U B.
A union B. Okay, that's A union B minus A. I should get A union B. And now we have to prove it. Okay, so we have to prove 2 things. We have to prove that term by term, this is in here. Okay, and then the other one around. All right. Is this an easy one? So this is my first set. And this is my second set. And I'm going to do the following. I'm going to start with an element in A union B minus A. And I have to convince you that it is in A union B. Is this, you think, easy? What do you think? Suppose X in A union B minus A. Means either it's in A, so it's in A union B, or in B minus A. But if it's in B minus A, it is in B. Therefore, it's in A union B. Okay, so let's do that. Let X be in B, A union B. Then X is in A, so there is A union, or X is in B minus A. Definition of union. So I actually don't know where my X is. It's either in A or it's in B minus A. So I take 2 cases. If it's in A, then it's also in A union B. If it's in B minus A, then X is in B. I don't need A, but it has to be in B. It's in B minus A. So it has to be in B union A. So in both cases, we have in A union B. So we have A union B minus A, a subset of A union B. Now the other one. That's the other one that we have to think a little bit more about. Now I want to show you, oh, you have to convince me that A union B is a subset of that. You have to convince me that any element in here is in here. All right, let's get going. Simon, would you like to start?
First, we would say let X be in A union B. Then X is in A or X is in B.
Okay. All right. Keep going. All of you, keep thinking with him. Let's all think together. I have to land here, remember.
So would we have two cases because of the or statement?
We have to, because I don't know what
Okay.
X is.
Okay.
You understand why we have two cases?
Mm-hmm.
So if it's an A union B, means it could be in A or it could be in B. So I don't know really what it is. But you have to prove that regardless what it is, at the end it's right there. Understand the logic?
In the case where X is an A, we can just say X is an A and we're done with it.
Suppose X is in A, not X in A, you have to say that it's an A union.
Yeah.
Because that's where I'm heading. Done with that.
Okay. And then in the case where X is in B, X is...
Okay, that's A, that's B. If it lands in A, I'm safe. Now what happens if it lands in B?
Do we have like two other
X
cases?
is-
Keep going, keep going. You guys are on the right track.
So the first one will be X only be in the B, and the other one will be X be
B intersect A.
yeah.
So, I don't know. I mean, it feels like you should just be able to ignore the B intersect A part because it's in A, so it's in
No,
A.
we can't ignore anything. We have to make it, we
Okay.
have to make it logical.
So
Okay.
Okay,
So
yeah,
X
see with me,
is
I can't
in-
ignore it. We have to make it a really logical argument.
So X is in B. So if X is in B, interrupt A. So X is in A. That's why like X can be A union and B minus A. And if X is in B minus A, so X will be A union B minus A. So
Okay.
like you have like a two case in B.
Right, now I'm gonna make your cases even clearer.
Okay.
Okay, very clear. Okay, how do you think I can make his case crystal clear to you? Okay, if X is in B, I'm gonna say two scenarios can occur. And either this X is in A, which reflect what he wants to tell me that it's in A intersect B, or it's not in A. By doing this, I'm very safe. I'm covering all my bases. So that X is in B is either in A or not in A. I don't have any others. Now I take two further cases. If it's in B and in A, so now because I have my or, then X is in A. So, as you guys said, it's in A union B minus A. So I split my cases in two to be very clear that, you know, I cover all possible cases. It's in B, either it's in A here, or it's not in A. I cannot have any other possibility. Now, case 2. Suppose X is in B and X not in A, then X would be in B minus A. So I took an X in B and I said, okay, if it's in B, either it's in A or not in A. If it's in A, it's in A union B minus A. If it's not in A, it means it's in this piece. So it means X is in A union B minus A. So regardless what my X is, whether it's in A or in B, if it's in A, it has to be in A union anything. If it's in B, okay, I ran into problem. I need to get to B minus A. So I said, I cannot get to B minus A. If it's in B, it's not in B minus A necessarily. So what you guys did was split it. If it's in B, either it's in A or not in A. If it's in A, I'm safe. If it's not in A, it means it's in B minus A, this piece right there. Therefore, I am done. So we have the equality that A union B is definitely a subset of that. And hence I have the equalities between them. The equality makes sense. If I take A, I add to it what's in B and not in A, I should definitely get everything in A. Okay. Right. Now, those ideas of proving, so far I really emphasized a set A, a set B, but those ideas, we can use them to prove, you know, equalities between or inequalities, or inclusion between any two type of set. So let me start with something, and next time we do more of those. So because I'm still practicing, I'm still want to practice this approach. Okay, suppose it's a simple one, not hard. Let us remember what's the power set of a set. Power set of A are all the set S, or the subset of A. Okay, so S is an element of the power set, means S is a subset of A. Okay, these are the power set. In case you forgot it, we have to review. Let us say I ask you to prove the following. So suppose I prove the following. So show that if I take the power set of, don't be afraid, it's not hard. It's actually easier than the one we did. Of A intersect B, so I take two sets, A intersect B. I compute it, I take all their subset. And this is the same thing as taking all the subset of A intersect all the subset of B. Okay. So we want to prove this. Remember, the power set is a set. But the only weird thing about it is that its elements are subsets. And this is another set. So basically, I want to show inclusion between two sets. So I will start with the first one. So suppose I want to show that this is a subset of that. My logic will not change at all. We'll do it exactly the same idea. I'm going to start with an element in here. And I want to show that if I start with an element in here, you have to convince me that this element is right there. So the logic is the same, but now we can take other sets. So let's do this inclusion. Okay. What should I start with? Let. What's going to be the first word?
Let S be the subset in A inter B.
Right. So, but is that, yes, you're absolutely correct. So I'm going to say, what do you want to call it? S?
Yeah, just make S.
Right. Let S be an element. I'm going to start with element. Just to tell you that I'm not changing my logic. Let S be an element in here. I want to show it's an element in here. Okay, so we always start with an element, and then we go here. Now let S be an element of the power set. What does this mean? What does it mean to be an element of the power set? It means S is a subset
Oh, yeah.
of A intersect B. Okay, so term by term, element by element. We do not change the logic of it. Now, you have to convince me that it's an element of the power set of A intersect the power set of B. Okay. So, who can finish it in 2 minutes? How can I get here?
So S is a subset of A, and S is a subset of B.
To have the subset of A intersect B, it means if it's in the intersection, that's A and B. If S is in the intersection, it means that S
Subset of A, and S is a subset of B.
and it's a subset of B because that's where I'm heading. So where is my S?
S in A, and the power of A.
Right, is an element of the
Okay.
power set of A,
And S is a power set of B
an element.
in element.
So S is, by definition of intersection, is an element of the power set of A intersect the power set of B. Definition of intersection. Okay, and that's my first inclusion. All right, definitely I need to stop right here. You guys know that your homework 6 is on Brightspace. You guys, I hope you started. And for Monday, I really want you to go over what we did in class today. I mean, it's crucial. It's the only way you guys learn. So my advice to you is just take the problem I did, take it, do it by yourself, and see if you can do it. Okay, and then go back to the notes and see if you are really getting it. That's actually the only thing I would like you to do as far as this is concerned for Monday, because that's how you're going to have a feeling of what's going on. Just do again what we did. And that will help you tremendously with those problems. All right. If you have any difficulties with homework number 6, please just email me and I can arrange a Zoom meeting with you to help you out with it. All right. Any questions?
So for this problem, you said definition of intrusion or
Intersection.
intersection. Okay.
Any other questions? Okay, bye-bye, guys. See you on Monday.